Hello everyone and welcome to lesson 6 of our intro/algebra review. Today we're going to be simplifying radicals. So the two properties that we're going to use today are the product property, which says if you have two numbers, two factors underneath a radical sign that you can separate by multiplication, you can give them each their own square root sign. And then the quotient property says if you have a fraction underneath a radical sign, you can give both the numerator and the denominator their own square root sign. Okay, so the way that we're going to be able to tell that a radical is in its simplest form is if there are no perfect square factors, so other than one, underneath the radical sign. Okay, so like square root of 8, for example, has a perfect square factor. So what we're going to do now is talk about the first 15 perfect squares. So the way you get a perfect square is you take a number and you multiply it with itself. So 1 times 1 is 1. That's our first perfect square. 2 times 2 is 4. 3 times 3 is 9. And then so on and so forth. So we get 16, 25, 6 times 6 is 36, 7 times 7 is 49, 8 times 8 is 64, 9 times 9 is 81, 10 times 10 is 100, 11 times 11, 12 times 12, 13 times 13, 14 times 14, and 15 times 15. So here are the first 15 perfect squares. Another thing to note is that a square root is the inverse operation of something being squared. Just like multiplication, division are opposite or inverse operations, so are squaring and square rooting, adding and subtracting. You'll learn more in some advanced math classes, but for now, just know that square rooting a perfect square undoes the squaring. So what do I mean by that? Let's take a perfect square like 16. If I was to square root 16, what I am doing is I am square rooting 4 squared. So the square rooting and squaring undo each other and you would just be left with 4. So when you square root something, you're saying what number times itself would equal the product that I've gotten? What were the two identical factors? So what we're going to be doing today is we're going to be simplifying radicals using the product property and using the quotient property. So for example, our first problem says the square root of 20. That is not a perfect square, so that is not just going to get released like I do with 16. Instead, what I have to think of is what are the perfect square factors that go into 20? What is the largest perfect square factor? So what I would do is I would start with perfect squares, the first one that's lower than 20. So the first one I see here is 16. Is 16 a factor of 20? No, it's not. Is 9 a factor of 20? No, it's not. Is 4 a factor of 20? Yes, it is. So what I could do is I'm going to rewrite the square root of 20 as the square root of 4 times 5. Now, I could separate these. The square root of 4 times the square root of 5. And some people like to write 4 instead of as a 4. They like to write it as 2 squared times the square root of 5. However, if you just recognize that square root of 4 is another way to write 2, that's fine too. Remember, squaring and square rooting undo each other, so I would have 2 square roots of 5. Okay, let's take a look at our next example, number 2. We have the square root of 27. So if I'm going to be looking for numbers that are smaller than 27, the perfect square factors. 25 does not go into 27. 16, no. 9, yes. So I could rewrite the square root of 27 as the square root of 9 times 3. I always like to put the perfect square factor first. So now I could separate these and write this as square root of 9 times the square root of 3. The square root of 9 is a different way to write the number 3. However, if that confuses you, rewrite this as 3 squared times the square root of 3. Taking the square root of a square they undo each other, the inverse operations, so we have 3 square roots of 3 as my final answer. All right, let's take a look at number 3 here. We have the square root of 125. Again, you are looking for the biggest perfect square factor that goes into 125. So look at the list starting at numbers smaller than 125 and rewrite it as 2 factors and simplify it. So please pause the video. I will write down the answer and you could check it after you're done. All right, so the answer that you should have gotten is 5 square roots of 5. If you didn't get that answer, please ask your teacher tomorrow. All right, so what happens for something like number 4 where we have a constant in front of our radical? Well, the constant just kind of comes down and hangs out while we still try to simplify this radical of square root of 60. Okay, so we're looking for factors that are perfect squares that will go into 60 smaller than 60. So the first one's 49, no. 36, does that go into 60 evenly? No. Does 25? No. Does 16? No. Does 9? No. 4 does. So it's 4 times 15. Now you could separate these two, that's the product property, so it's square root of 4 times the square root of 15. The square root of 4 is another alternate way to write the number 2. So what we have here is negative 2 times, instead of square root of 4, we write 2 and then times the square root of 15. Negative 2 times 2 is going to give us negative 4 square roots of 15. Number 5, we have 2 radicals that are being multiplied. We have 3 square roots of 2 times 8 square roots of 3. So when you have this case, what you can do is you multiply the coefficients in front. So 3 times 8 is 24. And then you can multiply what are these numbers underneath the radical sign are called the radicands. So you would multiply those together and we get 24 square roots of 6. So now once you do that, you do have to make sure, can you simplify the radical? Is there any perfect square factor other than 1 that goes into 6? 4 doesn't, 1 does, but we don't care about 1, so this would be our final answer. All right, for number 7, which should be number 6, I see the numbering is wrong here, but that's okay. All right, what we have is 4 square roots of 5 that's being squared. Anytime something is being squared, that means you take it and you multiply it with itself. So we'll have 4 square roots of 5 times 4 square roots of 5. Just like the previous problem, I could take the numbers in front, the coefficients, I can multiply those together. 4 times 4 is 16 times the square root of, and then I multiply the radicands together. So I get 25. The square root of 25, don't forget, I'll write it the other way now. I could rewrite 25 as 5 squared. Squaring and square rooting undo each other. So now what I have is 16 times 5, and that is going to equal 80. All right, so these last few problems on this page are going to deal with the quotient property. So each of these is going to be a little bit different, and as you become used to these problems, there's certain things you're going to look for and search for that will make the problem easier for you. So the first thing we have is the square root of 8 over 72. Now, typically, you're going to want to check, can I reduce this fraction right off the bat? And 8 over 72 does reduce to 1 over 9. So now if you look up top to the product or quotient property, you can separate the numerator and denominator so they each have their own square root sign. And now, hopefully you see the square root of 1 is 1 and the square root of 9 is 3, and you're done with that problem. All right, number 9, we have the square root of 18 over 3. This is different. I don't have a square root sign over both of them, so I can't simplify this and say it's the square root of 6. That is very, very wrong. They both have to have a square root sign in order for you to be able to simplify. So instead, what we're going to do is we're going to take the square root of 18 and simplify that. 18 can be rewritten as 9 times 2. Why did I do 9 times 2? Because 9 is a perfect square. Yes, 18 is also 6 times 3, but 6 is not a perfect square, 3 is not a perfect square, so doing it that way would be pretty much pointless. Okay, so now, if I was to rewrite these separately if I want to, I don't have to do this step that I'm doing right here. The square root of 9 times the square root of 2, square root of 9 is 3. So this is going to equal 3 square roots of 2 over 3. Okay, now I see that I have these 3's in common, and those can be canceled because they're both outside of the radical sign. So I'm left with square root of 2. All right, these last two I'm going to want you to try on your own. I'm going to give you a hint for number 10. Separate the radicals. All right, so write it square root of 18 over square root of 25. Hopefully you notice something about a perfect square, and then you could simplify the numerator. And then for number 11, my hint is going to be to reduce that fraction and see what kind of numbers you have. So go ahead, pause the video. I will write in the answers and you could check to see if your answer matches mine. All right, number 10, you should have gotten 3 square roots of 2 over 5. And for number 11, you should have gotten 4 over 3. If not, please make sure to ask your teacher next time you see them. All right, so on the back here, we have a bunch of problems. I'm gonna do some of them with you, some of them I won't, but it's kind of a mixture of different types of properties. We're gonna do some adding and subtracting, so I'll talk about the rules with radicals and that. Yeah, so let's just jump right into it. So here I have 2 square roots of 5 over square root of 64. Now the radical parts could be reduced, okay? I could simplify 54 and I could simplify 64. And I would get 27 over 32 because I could reduce both by a 2 and then I have to simplify each radical. So what sticks out to me right away is this 64 because the square root of 64 is a perfect square. So I could rewrite this as 2 square roots of 54 over 8 because... Sorry about that bell. Okay, because the square root of 64 is 8, I could just rewrite that. Now, here, because these are just factors, these are terms, top and bottom, I could simplify 2 and 8, leaving me with square root of 54 over 4. Because 2 goes into 2 once and into 8 4 times. Now, square root of 54 has a perfect square factor in there. It's 9 times 6. And then I just bring along the 4. The square root of 9 is equal to, don't forget, 3 squared times 6. So I'm trying to write this in different ways for you so you get used to whichever way you prefer. If I square root the 3 squared, a 3 escapes. It's 3 root 6 over 4. This is my final answer. Please don't think and don't get confused and think that this 6 and this 4 could be reduced because one is underneath the radical sign and one is not. You just have to leave that as your answer. And again, if you did this a different way, if you went and reduced 54 and 64 right off the bat, because those were both initially underneath the radical sign, that would be okay. You would still get the same answer. It just maybe would take you more steps. You'd have more simplifying to do. You would possibly have to do something called rationalizing a denominator, which we haven't done yet. So there are different ways to get to the same end result. All right, number 2 over here, we have square root of 2 over times the square root of 27 over the square root of 3. Again, you could do this a multitude of ways, and as you practice this, you will get better at recognizing which way is maybe the most efficient and best, easiest maybe way. But what I see here is I have these 2 radicals that I can reduce. So I would have square root of 2 times, because they're both underneath the radical sign, I could reduce those, and it's going to be the square root of 9. Because 27 divided by 3 is 9. The square root of 9 is 3, and then square roots of 2. I don't like to write it like this, and hopefully it's obvious why I don't like to write it like that. It looks like square root of 2 times 3 looks like maybe a square root of 23, so it's just a little bit dangerous to do it that way. All right, so for number 3, we have radicals that are being added and subtracted. Radicals are very similar to variables, in that you can only add and subtract ones that are like radicals. So here, if I have 6 root 3 plus 2 root 5 minus 7 root 5 plus 2 root 3, I can only combine these 2, and then I can only combine these 2, because they need to have the same number underneath the radical sign. So 6 root 3 plus 2 root 3, just like if it was 6x plus 2x, you combine the coefficients, it's going to be 8, and then that radical just kind of comes along with it. 2 root 5 minus 7 root 5 is like if I had plus 2y minus 7y. I could combine the coefficients. It's going to be minus 5 root 5. The radicals stay the same. You don't do anything with the number underneath the radical sign when combining by adding and subtracting. All right, so number 4. We're adding 2 radicals. Notice that the radicands are different numbers. One is a 75, the other one is a 27. That doesn't mean this problem is impossible. It just probably means that what you're going to have to do is simplify each radical. So what I want you all to do now is take 2 root 75, simplify it, and then 3 root 27, simplify it. Hopefully what you end up with is the same number underneath the radical sign, and then you could combine the coefficients. So it's like 2 problems from the first page, and then at the end you're going to add them together. Okay, so go ahead and try this problem, pause the video, and then come back and check if your answer is correct. So the first term, 2 root 75, should have become a 10 root 3. And then your 3 root 27 should have simplified to become a 9 root 3. Notice how now they both have the same number underneath the radical sign. Both have a square root of 3, square root of 3. So therefore you can just combine the coefficients. Okay, number 5, we also have 3 terms that are being combined. Initially, they do not have the same numbers underneath the radical sign. They have a 50, a 20, and then a root 5. So you're going to have to simplify each one individually and then see if any of the numbers underneath the radical sign are the same. Go ahead, try that problem, pause the video, and I will display the answer. All right, so 20 root 2 minus 5 root 5 is what your final answer should have been. That means that these 3 terms, when you simplified them, you didn't end up with 3 of the same numbers underneath the radical sign. Only some of them could have been combined. But your final answer is 20 root 2 minus 5 root 5. There's nothing more that you could do to simplify that. All right, let's take a look at number 6. Here we have something that we haven't seen at all yet. We have 5 plus the square root of 27 over 9. Now, our numerator has 2 terms. So what we have to do is go ahead and simplify this radical. It's going to be 5 plus, I'm going to rewrite 27 as 9 times 3 over 9. Now, I still cannot simplify anything except for the radical. So I'm going to have 5 plus 3 square roots of 3 over 9. At this point, you have to make sure that, and I'm going to draw this little heart, all of the numbers that are not underneath the radical sign, all of the outside numbers, that heart, if those 3 numbers have something in common, a factor that you could divide out of all 3 of those numbers, then you can simplify this fraction. So because 5 and 3 and 9 have nothing in common, I leave my answer as is. Because the 5 in the numerator doesn't have a radical 3 next to it, I can't combine it with that 3 root 3. That does not become 8 square roots of 3 because 5 does not have that radical. Okay? So it has to be all of the numbers that are on the outside, they have to have a common factor, then you could reduce the fraction. If not, having, just these 2 have something in common, not enough. Having these 2 have a 3 in common doesn't do anything for you. It has to be all 3. All right, so let's go ahead and look at number 7 together. I have 10 minus the square root of 48 over 2. Now, all of these numbers are divisible by 2, but because the 48 is underneath the square root sign, right now there's a little 1 in front of there. These 3, 1, 2, 3, these 3 numbers that I just marked off, they have no factors in common. It's a 10, a 1, and a 2, so there's nothing I can do. So first I have to focus on this radical. 10 minus, the biggest square factor in 48 is 16. If you take out a 4, you're going to have 4 times 12. 12 still has a factor, so it's kind of like reducing a fraction and then having to reduce it a little bit more. But 16 times 3 is the square root of 48. So I rewrite the square root of 48 as root 16 times root 3. Square root of 48, square root of 16 is 4. So this becomes 10 minus 4 square roots of 3 all over 2. Now, here's where you draw your little heart. If those 3 numbers have a factor in common, you can reduce it. They do have a factor of 2. So I reduce 10 by 2, making it a 5. Minus 4 reduced by 2 is 2 root 3. And then in the denominator, I would just have 1, so it's not necessary for me to write that denominator of 1. If I did put this all over 1, that's okay. It's not incorrect. However, it just looks kind of funny. Okay, number 8. 4 plus the square root of 12. It's 4 times 3. Remember, right off the bat, I can't simplify 4, 12, and 8 because I need this number on the outside. Right now, there's an invisible 1 that's out there. This simplifies to be 4 plus 2 square roots of 3 all over 8. Draw your heart. Do 4, 2, and 8 have any factors in common? They sure do. They have a 2 in common. So I take out a 2, so it's going to be 4, if I reduce by 2 is 2. 2 divided by 2 is 1. I don't need that placeholder of 1. Again, if I put it there, it's not incorrect, but it's not necessary. I don't need it. And then 8 divided by 2 is 4. So my final simplified answer is 2 plus the square root of 3 all over 4. Okay, I would like you all to try number 9 on your own. Attempt this problem, check your answer. I will display it. Pause the video, try number 9. Okay, so what you should have gotten is that the square root of 200 becomes 10 square roots of 2 because there's a perfect square factor, or perfect square, factor of 100 in 200. And then all the 3 numbers on the outside were divisible by 2. Now this plus and minus sign is just an abbreviated way to write 2 different answers. The answers here would be -3 plus 5 square roots of 2 over 4, or over 2, and then -3 minus 5 square roots of 2 over 2. So those 2 answers are abbreviated by this little plus or minus symbol. Don't let that symbol scare you. I should have mentioned that in number 8. But this is your final answer. If you did not get that, please make sure to ask the next time you're in class. All right, that's it for this lesson 6, 2 parts. Thank you so much. Have a good day. Bye.